Right now, as you watch this, your phone has already made dozens of API calls. Every scroll, every payment, every notification. But here's the thing, not all APIs are built the same. There are 5 major API architectures every developer must know in 2026: REST, GraphQL, gRPC, WebSockets, and webhooks. Choose the wrong one and you will feel it at 2 a.m. when your system falls over. Let's learn all 5. API stands for Application Programming Interface. Think of it as a formal contract between two software systems. One side says, here's what I can do for you. The other side says, here is exactly what I need. The API is the language they use to communicate. The classic analogy, a restaurant. You are the customer. The kitchen is the server. The menu is the API documentation. Your waiter takes your order in a specific format. The kitchen processes it and your food arrives. APIs work exactly the same way. REST is the most widely used API architecture in the world, powering over 80% of public APIs today. It stands for Representational State Transfer. REST uses 4 HTTP methods as its vocabulary: get to read data, post to create it, put to update it, and delete to remove it. Clean, predictable, universally understood. REST is stateless. Every single request contains everything the server needs to respond. No session memory between calls. This makes REST naturally scalable, easy to cache, and consumable by any HTTP client in any programming language. That universality is why REST became the default. But REST has 2 chronic problems. Overfetching. You need a user's name and photo, but the server sends you all 40 fields of their profile. Underfetching. You need data from 5 different endpoints, so you make 5 separate round trips. This inefficiency at scale is exactly what gave birth to GraphQL. GraphQL was invented by Facebook in 2012 to solve REST's data problems and open-sourced in 2015. The core idea is powerful. You describe the exact shape of the data you need, and the API returns precisely that. One single endpoint, infinite flexibility. In REST, fetching a user's profile, their posts, and their friend count requires 3 separate API calls and 3 round trips. In GraphQL, you write one query that requests all 3 in a single network request. The client controls the data shape, not the server. This is a fundamental shift. GraphQL also ships with a strongly typed schema, a machine-readable contract of everything your API can do. This unlocks exceptional tooling, autocomplete in your IDE, automatic documentation generation, and type errors caught before they ever reach production. GitHub, Shopify, and Twitter all run their APIs on GraphQL. gRPC was built by Google and released in 2016. It solves a completely different problem. What happens when REST and JSON are too slow? gRPC uses protocol buffers, a binary serialization format that is 5 to 7 times smaller than JSON and dramatically faster to parse. Less data means less time. gRPC runs on HTTP2, which adds multiplex streams, header compression, and server push built in. The result is latency that drops from 80 to 100 milliseconds with REST JSON down to under 20 milliseconds with gRPC. For microservices exchanging thousands of messages per second, this is not a nice to have. It is a hard requirement. gRPC supports 4 communication patterns: unary, one request, and one response, just like REST. Server streaming. The server returns a continuous stream of responses. Client streaming. The client sends a stream. And bidirectional streaming, where both sides send simultaneous streams. Netflix, Uber, and Dropbox all use gRPC at their microservice layer. REST, GraphQL, and gRPC share a fundamental constraint. The client always initiates the conversation. But what if the server needs to push data the instant something changes? Live scoreboards, chat apps, collaborative editing, trading terminals, polling with REST means hundreds of wasted HTTP requests every single second. WebSockets solve this with a single persistent bidirectional connection. The handshake happens once over HTTP, then upgrades and stays open. The server can push any data to the client the moment an event fires. No polling, no wasted round trips. Slack, Discord, Figma, and every real-time app on the planet runs on WebSockets. Webhooks are the inversion of REST. Instead of your application repeatedly polling an external service asking, "Did anything happen?" Webhooks let that service call you the instant an event fires. You register a URL once and forget about polling entirely. Stripe calls your server the moment a payment completes. GitHub calls you when a developer pushes code. Twilio calls you when a message arrives. Your server receives a post request with the full event payload, processes it, and responds. No persistent connection, no wasted compute. Webhooks are the most efficient pattern for reacting to external events. Let's compare all 5 architectures side by side. REST is universal and beginner-friendly, but rigid in data shape and prone to overfetching. GraphQL is flexible and precise, but adds schema complexity and requires a more sophisticated server. gRPC is extremely fast, but binary only and harder to debug with standard browser tools. WebSockets enable real-time at scale, but require managing persistent connections and reconnect logic. Webhooks are efficient and event-driven, but need a public endpoint and robust retry handling for failures. The best API is not the most advanced one. It is the one that best fits the specific problem you are solving. Here's your 2026 API learning roadmap. Stage 1, master REST, learn HTTP methods, status codes, authentication with JWT, and OAuth 2.0, request headers, and API versioning strategies. Build a complete CRUD API from scratch. This is the foundation that every other architecture builds on. Give it 2 to 3 weeks. Stage 2, learn GraphQL, design a schema with types and relationships, write queries and mutations, understand resolvers and the N+1 query problem, solve it with data loader. Use Apollo Server or GraphQL Yoga. Expect 2 to 4 weeks of focused building and iteration. Stage 3, explore grpc. Define your first service contract and protocol buffers. Generate type-safe client and server code. Implement unary calls and then streaming patterns. This step is most valuable if you are building backend microservices or working on high-throughput systems. Stage 4, master real-time and event-driven patterns. Build a WebSocket server with rooms, broadcasts, and reconnection logic. Set up webhook endpoints with proper signature verification and idempotent handlers for retries. Build something live, a collaborative canvas, a notification feed, a live data dashboard. Feeling the patterns in a real project is what makes them stick. In 2026, AI has fundamentally changed how we work with APIs. Tools like Claude and GitHub Copilot can generate full REST clients from an open API spec in seconds, write GraphQL queries from plain English, and scaffold gRPC stubs from proto-definitions. The iteration speed is unlike anything before, but AI amplifies the advantage of developers who understand the fundamentals deeply. Knowing why REST fails at real time, why gRPC beats JSON at microservice scale, and when webhooks outperform polling, that judgment cannot be generated. It comes from building systems and understanding the trade-offs. Master the fundamentals. Use AI to move faster. That combination is genuinely unstoppable. 5 API architectures, 5 distinct trade-offs. REST for universal CRUD with simple rules, GraphQL for flexible, precise queries from diverse clients, gRPC for high-performance microservice communication, WebSockets for bidirectional real-time data, webhooks for efficient event-driven integrations. Know all 5. Understand their trade-offs. Choose deliberately. The architecture of your API is the architecture of your system.